All right, so the purpose of this is to figure out when a reaction will be spontaneous. And to figure that out, we need to know about these two driving forces. So you have enthalpy, which is essentially for our purposes heat, and we have entropy, which again is randomness or disorder. And they can either be positive or they can be negative. So for example, you can have a reaction which releases heat, so it has a negative enthalpy, and that produces more disorder. So it's got a positive entropy. On the flip side, you can have a reaction that receives heat, so it's positive, but makes less entropy and is negative. So there are four combinations you can have here. They can both be positive, they can both be negative. And what we really want to know is what effect this has on delta G. Delta G tells us if a reaction is going to be spontaneous or not. And the key thing is if it's negative, the reaction is spontaneous, meaning it can occur on its own without any real help from us. So we want delta G to be negative, presumably, if we want a reaction to occur. And the formula for delta G is that delta G equals delta H minus the temperature in Kelvin times delta S. And so this reaction helps us figure out the sign of delta G. For example, if delta H is negative and delta G is positive, so for example, if delta H was negative 10, and delta S was something like 50. These are not anywhere near realistic numbers, but just to give you an idea. Negative 10 minus some temperature times 50, it doesn't matter what the temperature is, because the temperature can only be positive. This is in Kelvin. A negative number minus a positive number, no matter what you do, will always give you a negative number, always. So that means that with a negative delta G and a positive delta S, this will always be spontaneous. And that should make sense because this represents an exothermic reaction, which the universe likes, and this represents more entropy, which the universe also likes. So both driving forces are going towards the reaction occurring. So that will always occur because delta G is always negative. On the flip side of that, if delta G is positive, let's say it was a number like 50, and delta S were negative, so minus T times some negative number, negative 10. So 50 minus T times negative 10, a positive minus a negative, no matter what you do, whatever the numbers are, will always be positive, always. So if delta G is always positive, this reaction can never be spontaneous. And so that should make sense because this is an endothermic reaction, which we don't like, and this is less entropy, which we don't like. So neither of these driving forces want the reaction to happen, so it will never be spontaneous. Where we get into a little bit more confusion is when you have one driving force which likes the reaction, like this is an endothermic reaction, which we don't really like, but this produces more entropy. So one of these driving forces is going towards it, and one is going against it. So what will the sign of delta G be? Well, it depends. What does it depend on? Well, if delta H is positive, let's say it were 100, and you're subtracting a positive number, say T times, let's say delta S were 10, and again, these are not really realistic numbers, but just to give you an idea, what's going on here? So when is this going to be negative? Well, if we look at it, if T is really small, let's say T has a value of 1. So if T has a value of 1, this is going to be 100 minus 10. This is going to be positive. So that's not going to work. But if T is larger, let's say that T had a value of 20, then we have 100 minus 20 times 10, and 20 times 10 is 200, so that gives me negative 100, so that's negative. So we notice that as temperature gets larger, the delta G becomes negative. So when is this spontaneous? This is spontaneous at high temperatures. So at high temperature, delta G is negative. And so that is when this will be spontaneous. Now, what is high temperature? It all depends on the reaction. We can't really quantify when it becomes a high reaction, a high temperature, without knowing the values. In this case, a high temperature would be when T is 10. Anything larger than 10 will give us a negative number, because 10 times 10 is 100, so if T is larger than 10, that would be considered a high temperature. Again, these are not really realistic numbers. All right, going to the last case. You might be able to guess what this is already. If delta H is negative, let's say it was negative 30, and delta S is negative, so negative 10, we can say, all right, what is the temperature there? So again, here, let's say T equals 2. So when T equals 2, you get negative 30 minus 2 times negative 10. So it's negative 30 plus 20, which is negative 10. That's negative. That works. What happens when T equals 10? You get negative 30 minus 10 times negative 10. So that's, let's see, that's not going to work because it'll be negative 30 plus 100. So we'll give you a positive number. So this is going to be spontaneous at both temperatures. So that's pretty much how this works. You want delta G to be negative, it's going to be spontaneous. If it's positive, it will not be spontaneous. So until next time, I am Derek Genova. Have a delightful day.